So in the previous video, I designed this hanger for the P2. And in this video, we're going to be kind of setting it up and rewriting it, hopefully. So this one is just really, really thin walls. This is mostly just to see how well it fit and what the tolerances were, and that I got all the measurements right. And basically, I didn't have to change anything at all from the model that's in the previous video. This is exactly the same thing, and it's working out great. It's a perfect fit, and it should have the exact same function and geometry going on as a stock other planet hanger. So, the other thing I want to talk about in this video as well is what we're going to do about the axle. So, there's a couple options. The simplest and easiest, and one that we like a lot, is threaded rod. Threaded rod is something we've used on dozens and dozens of hangers in the past. We've probably put hundreds of miles on trucks with threaded rods for axles. It's just really straightforward. You thread the rod into the hanger, and then you lock it in place with a couple of nuts. The big caveat with the threaded rod hangers is, in order to be strong enough with threaded rod, you have to size it up to 10mm axles. So, if you're already set up and running 10mm axles with other stuff and you've got 10mm bearings, that can be quite viable. But 10mm bearings aren't exactly standard. So an alternative to that might be grade 8 bolts. You can get these grade 8 bolts and you would be astounded at how strong a grade 8 5/16 inch bolt is. And you can get it the length of the axle you need, and it should do the job just fine. This is just so incredibly strong, so much stronger than the 10mm axles of threaded rod. So this is a truck that's designed around having those bolts, and there's a couple of caveats with that. First off, it's just kind of a different process to put it all together. And you have to put on your wheel on the axle, and then you have to put in a washer to distribute the load onto the 3D printed plastic, because the bearing, the inner race, without a washer would just dig into the plastic, and then you'd have everything rubbing. So, washer, another wheel. So this will get you an incredibly strong, pretty legitimate axle that's just a little bit different than from standard axles, and that works great. The third option is to use an actual axle. So this is an axle from an early P2 hanger, like this one. And basically, if your hanger's so beat up that you need to replace it, you can reuse the axle as the axle for your new hanger. And that's the third option, and that's probably the best option. But whatever you use, the size of the hole for the axle that's in the 3D printed hanger is probably not going to be accurate enough for you to get that axle in there. So for pretty much all the options, what you're going to want to do is get a drill . So basically, after drilling that out, it should be possible to press in your axle into the truck, and you might have to use a vise and a rubber mallet or something to get it in there. In these early trucks here, we actually had a hydraulic press to just physically shove them in. If I was to do that on this one, I could probably do it, but the walls are so thin, and I removed materials, so now they're even thinner, so it might split this hanger. It should be a nice snug fit doing that. Alright, so I'm going to try this. I'm going to see if I can hey, there we go. That should be in there pretty good now. That probably would have melted the plastic. It's probably melted right in there. So that should actually be pretty good, just like that. And I didn't even split this hanger, so that's good. So So believe it or not, this is actually probably tough enough to go out and do riding on for a little bit, because basically all the strength of the entire hanger is coming from the axle. The plastic, all the plastic is doing is just making that axle a useful shape to fit in to the base plate. And really the only spot where the axle is doing a ton of work is at the bottom of this slot, because the bolt goes to the bottom of the slot and actually pulls pretty hard as it compresses the edge of the cam. So there's actually quite a bit of force on this one particular spot here when you're leaned totally out. But aside from that, if you're not leaned totally out, all the forces are going to basically be side loading onto this slot here and pressing on these flat surfaces here and here, press against the channel walls. And basically it's distributing the force over large areas, and so there's not a whole lot of strength required from the plastic itself. I think the last step is just to go out and stick this on a board and ride it. And once I know this is going to work well, I'm going to publish the model on Thingiverse, and I'm going to put a link on that on both videos. And I'll also have the Fusion 360 model so you can mess around with your own parameters. So let's ride this, and we'll see if I can break that bridge at the bottom of the slot with this minimal material hanger. See how much confidence this will give us. Alright, I think I just heard the slot snap. Wait, no. It wasn't the slot that snapped. Look at that. The hanger just snapped. So, let's do, so the camera wasn't recording, unfortunately, but I just smashed the wheel into the curb, or just slammed the board onto it, just to see what would happen. And, looks like it just blew the axle right out of there. So you can see just how incredibly thin this was. So that was riding. So I'll do the same thing on the real hanger, and we'll see how that takes it. So what it's doing is look at that, look what they did to the wheel. Yeah, it's pushing the axle into the channel wall, and there's just not enough material on this axle to keep that from collapsing in. There's a lot of space between the wall perimeter and the axle perimeter. All right, so let's get back to the bench and have a closer look at that. I'm gonna keep riding it. Still rideable. There's nothing to keep the axle from slipping sideways, see? It's hilarious. Whoa! I felt it just like zook. That threw me off. I could have stayed on it, but I panicked. All right. All right, so this is what it looks like. all taken apart. This is the piece that flew off. Very destructive. Definitely more infill than that. Alright, I would say you probably want to print with enough perimeters so that the bottom of the slot is solid. And you probably want to arrange it so that it's solid around the axle itself, so that especially between the channel walls and where the axle is sitting, because there can be potentially a lot of compressive load there when the wheel hits stuff, and we don't want that to crack. So I think those are the weak spots. Alright, so I think I'm pretty happy with all that. I think I'm even happy with how much writing I was able to get out of this thing, with how weakly I printed it. So there we go. Go make your own hangers. Longboard technology. Over and out.